Hello, everyone. Hi, I'm Chris Wysopal, the founder and chief security evangelist for Veracode. We're an application security risk management company, and I'm here to talk about the challenges that we're seeing today with people trying to secure their applications and how we're not keeping up, we're not keeping pace with the code velocities we're starting to see today. And one of the challenges is generative AI-based coding is just increasing that problem. I come from the hacker world. This is me testifying in front of the Senate. That's me with the blue arrow back in 1998. I came from the hacker world, the vulnerability research world, and then decided to change my career from a software engineer to go into the cybersecurity realm because I saw what challenges we were going to see over the coming years with the growth of the internet and all the new technologies that we were going to need to secure. And this is me being the cybersecurity Grinch at a conference with a lot of builders. The bad news is we're finding software security flaws faster than we can fix them. We've gotten really good at finding issues. We scan code in development, we find problems, but developers want to go really fast. They want to build functionality. They want to make their customers delighted. Oftentimes, the thing that gets traded off is actually fixing security problems that we know about. And so what we're seeing as applications age, they get more and more insecure. Here on this chart, this is a chart from over 1 million applications that Veracode has scanned over the last couple of years. And we find that over 50% of 2-year-old applications have security flaws in them. They're shipping security flaws to their customers. And after 5 years, almost 70% of applications, this is the problem. So we see as applications age, they get less secure. And this is just because it's like technical debt. We just defer fixing security issues. So this is what we have seen from our last report. When we looked across all the applications, 70% of applications had security debt. And so our definition of security debt is you found a particular security flaw in your code using some sort of security scanning tool. You want to fix it. Your policy is to fix that severity or that class of problem, like SQL injection or buffer overflow. But then you decided, I'm going to wait. I'll fix it later. And if you've waited more than a year, so we define that as your security debt. You're probably never going to fix it if it's gone on that long. And we also define critical security debt as those critical issues that have a critical impact if exploited. And it turns out that 40% of organizations have decided to defer fixing even critical issues. So this is a fairly large, widespread problem. I broke down some data between EU customers and our customers worldwide. And it actually turns out that the EU is doing slightly better than the average company from us worldwide. About 3% less customers are carrying security debt. So that's good news. But with the critical security debt, it's about the same. It's within 1%. Now, why is this happening, right? You think this would just be easy. The problem is, cybersecurity is hard. That's why we have so many problems in the software, and we're constantly patching software. Attackers are always exploiting these things, is because there's a lot of security knowledge gaps. Developers don't come out of school understanding how to write secure code or how to fix security issues, so they just don't know what to do in these cases, even when the tools are telling them you have a problem there. Applications are getting more and more complex. Cloud-based applications are so much more complex than the old, multi-tiered server applications. You have microservices, you have containers, you have APIs from your cloud service provider you're using. The applications are very complex, and that means that we don't really understand the risk. So some of the risks we're able to find are probably worse. Some probably aren't as bad as we think they are because there's all this hidden complexity that we don't really understand. And that just puts a cloud over doing any kind of security remediation. And finally, the evolving threat landscape means that code you wrote yesterday could become risky today. You might have used an open source package that you thought was fine, was secure, and yesterday someone found a security vulnerability in that open source package that now affects your application. Or they find a vulnerability in an application that's in a layer of one of the containers you're using. Now you're insecure. So there's this constant moving target, which obviously is frustrating for developers. So what we really need to do is figure out how to fix things better. So that's sort of the backdrop that we've been seeing change over time. But now we all know that generative AI is great for coding, right? It's going to help us all code faster, increase velocity. But guess what? One of the big challenges with this is it doesn't actually write secure code. It writes code much like a developer writes code because it's learned on open source code. It's learned on the code bases that are available out there. So generating code is one of the big use cases for generative AI by developers. Also just understanding code reviews, fixing bugs, that's good, right? Doing code translation, creating unit tests, writing documentation. These are all use cases that we're seeing grow over the last year. And there's some more emerging use cases that developers are using it for. They're actually diving into huge code bases when they get onboarded to a project to start to understand them. Looking for answers to programming questions. How do I do this task securely? How do I use this API? How do I do cryptography? I saw a data point that 11% of a developer's time is used searching the internet to answer a question that they have that they need to answer before they can complete a task. Generative AI can answer those questions quicker, but the problem is, are those answers correct, right? And that's one of the challenges, because a lot of times when we use generative AI, we use it as an assistant to a human. The human's the expert. The AI lets them go faster. But what happens if the human generally doesn't know the answer and is asking generative AI the question? It doesn't know if it's right or wrong. So even if it's only wrong 20% of the time, that means that human's going to be wrong 20% of the time. And this is one of the challenges we're seeing using generative AI in the development context. Reading log files to do debugging. Debugging is very painful for developers. Having AI scan through log files, make connections between different errors in the log files that might be hundreds of lines of log apart. That's something that the AI is actually really good at. So we're seeing it really help with debugging. Creating functional tests. And finally, remediating security vulnerabilities. That's the thing that really excites me. And one of the things we're working on at Veracode is we think this is really the only solution to the code velocity we're seeing today, is we need to automate the remediation of vulnerabilities in code. So here's a diagram of how large language models were trained and work for writing code. Developer prompts something like Copilot. I need you to parse this JSON file. That LLM read a lot of open source. It read a lot of code that was parsing JSON files. So it's learned how to do that. The challenge is it's also learned how to write code insecurely because it's learned from the average code base. It's also learned from code that was written 10 years ago when we really didn't know how to do code securely for certain things, and we've learned over time. Older code is less secure code. The LLMs have all learned how to do this. One study from NYU University found that 41% of code generated from Copilot when it was prompted by the researchers had a vulnerability in it. That should scare everybody. The fact that these tools are being used by developers and they're helping them create code faster, but they're also helping them create more insecure code faster. So here are 4 different studies that kind of illuminate this problem. One was at Wuhan University. What they did was they searched through open source to identify code that was created by Copilot in this case. And they took that code, they did a code review on it, ran security scanning tools on it, and they found that 36% of those snippets of code that they could identify were written by generative AI, had a vulnerability in it. The NYU study I just mentioned They wrote 1,689 programs, and then they looked at all those programs, and they found that 41% of them had security vulnerabilities in it. So a lot of times people assume that because the code is functional and it looks like good written code, it's also secure code. And that is an assumption that developers make all the time, and it gives them a false sense of security with this generative AI generated code. Stanford took a different tact, and what they did was they did a control group of developers that wrote code the traditional way with no Gen AI, and a group that wrote it with generative AI. And the generative AI group actually wrote slightly less secure code. They had more vulnerabilities in their code than the control group. So all these things mean that we really need to think about the implications of higher code velocity and higher developer productivity when it's just writing more vulnerabilities. In the interest of time, I'm going to skip over the Purdue University study, which is about Stack Overflow. So I have some data from our State of Software Security report where we looked across our customer base just to get a handle on how big the problem is. We looked at over 1 million applications, 96 million flaws that were found in those million applications, and we went to look at when was that flaw created and how long did it take to fix that flaw, or was it ever fixed? And what we found that was when we looked at the differences between code that developers wrote and code that they inherited because they used different open source packages, they found that with all security debt, so if you don't take criticality into effect, most of the problems are in the code the developers were writing. Only 10% was in the third-party code, 90% was in the team's code that they wrote themselves. But when we looked at those critical security issues, the things that were most important to fix and the ones that everyone wants to fix, we found that 65% was coming from the third-party code. So this is an insight that should help everybody who's trying to use these third-party packages. They really need to scan them and fix the vulnerabilities in them. I looked at a breakdown for EU in this case, and it turned out that a little bit more was coming from the third-party code in this case. So maybe it's a little bit worse. Maybe there's more third-party code usage in EU applications. I'm not sure why, but it's even more important to look at that code. And then we said, why is this happening? Why aren't people fixing these problems? Why are they letting them fester for a year or more? And it's fairly simple. It makes sense. It takes too long to fix issues, right? So it takes too many resources and too much time, and that time does not get allocated to fix these issues. Business decisions say, I need features, I need to fix my customers' bugs they're complaining about. This is something I can defer. So this is a conscious decision made by the business to say, I'm just not going to fix things I know about, right? Not fixing issues you know about, it sounds like negligence to me, right? It's like you have these issues. These are things you found. So when these eventually get exploited, it's not going to look very good for the business that they knew about the issue and they didn't fix it. So I have some tips. What can we do to fix this? We have to prioritize. We have to look at the critical security debt, whether it's a year old or less than a year old. It's kind of shocking for me as a cybersecurity person to not see things prioritized by risk, right? Because cybersecurity people think in risk. They say, if you only have a certain amount of time, fix the things that are most risky, right? That seems like the most efficient thing from a cybersecurity mindset. But the problem is that doesn't always seem to be the most efficient thing from the developer mindset. They fix the things they know how to fix, right? Because I can fix this one. I know how to fix this. This one I don't know how to fix. I don't want to go to training. I'm just not going to fix that one. So we have to solve these problems about why things aren't getting fixed. And one of the big ones is training the developers to understand this, and also to give them enough time to fix it, prioritize it as part of the business. And I did the split from EU apps versus the rest of the world, and it turned out that the EU apps were a little bit worse. They had 4.3% security debt versus 3%. That was critical. Now, this might seem obvious, but one of the solutions is to just figure out how to get your teams to fix security flaws faster so it takes less resources to do that. One is giving them the proper training, but the other one really is giving them the time to fix it right after it's found and not deferring it. Because as soon as you defer something, what's going to happen is the person who wrote the code probably isn't going to be the person who fixes the code. And that's going to make it take longer for them to do it. And it's just easier for people to not take ownership of code that they didn't write and make excuses on how to not fix it. So figuring out a process where you can fix things quickly after they're found is really going to help. And that's one of my takeaways. And deal with your higher code velocity. Right? This is something that every development team wants. They want to get efficient in writing more code faster, more functionality to the market. You're more competitive. That's why generative AI is being adopted to write code. I've seen statistics saying it makes a developer up to 40% more effective. That's great. That's 40% more code. But what are you doing to remediate all of those issues? This is something that is a sort of an unintended consequence. So you want to increase capacity to fix, you want to prioritize better, build good security habits, and finally, you want to use AI-assisted fixing. This is one of the things we do at Veracode. We have a product called Veracode Fix where we've trained an LLM to understand what bad code looks like and how to fix bad code. And we do this across 9 languages. I think this is really the only way that you can take advantage of code generation tools is to take advantage of code fixing tools at the same time. And I think that is one of the good solutions out there to this problem. So I have a few minutes left. If there are any questions that people have? Oh, back there.
Thank you. Can you say anything about differences across the programming languages? You sit on a fantastic data set.
Yes. So that is a really good question. Unfortunately, I don't have the answer, but I know it is in the State of Software Security report. So it's a report that's downloadable on our website, and we do split this data up by language, because language is very, very important. Anyone else? Oh, right up here.
Hello. So yeah, I have a question regarding the statement you made around like generally prioritizing based on risk. And using a lot of code review tools, generally speaking, they give results in the form of severity. And when you think about risk from a traditional sense, you kind of make a matrix based upon risk, based upon severity and likeliness of an exploit, for example. Yep. Do you think AI will be able to help us understand more thoroughly risk from a point of view of using these code scan reviewers to understand likeliness as well?
Yeah, that's a really good point. Part of understanding the risk is understanding what the code looks like when it's deployed. So a lot of tools just look at the code itself, but really to understand the likelihood of that code being reachable from an outside attacker, you want to look at the production environment. You want to marry the knowledge of the code base with the knowledge of that deployed environment, with what controls you have. Is it an API that's reachable from the internet, or is it something that's behind multiple layers of things? So you want to get a total picture of where that code is deployed, and there's some tools out there that can gather information from, say, a cloud environment programmatically and actually say, hey, this application's reachable. They can also do things like say, this application is processing sensitive data because this data store has been marked as sensitive, and I see this application is making connections to that. So prioritizing risk is a super important way to help bubble up the things you really need to fix. And I think we're pretty much out of time, so I thank you all for coming to see me today.